Hey everybody, and welcome to a lecture video on Fermi Problems. Remember that this is the part of the course where we're going over good informal forecasting practices, and one of those practices that's covered in Philip Tetlog's book is treating our forecasting problems as Fermi problems. So this video will go over what Fermi problems are. So Enrico Fermi, who Fermi problems are named after, was a famous physicist of the early 20th century. He made huge contributions to nuclear physics, won the Nobel Prize for physics in the 1930s, but was also famous for making incredibly accurate estimates of very random quantities using just back-of-the-envelope sort of guesstimations or calculations. So Fermi problems involve estimating an unknown quantity by breaking the problem down into subproblems that involve guesstimating relatively familiar quantities. So we can think of this as a method for coming up with estimates in domains where, at least initially, we have no idea what to estimate. So here's a classic example, right? It's taken from Philip Tetlog's book, of estimating number of piano tuners in Chicago, right? So the question is to estimate without Google, right, the number of professional piano tuners in the city of Chicago. When you first look at this, right, if you ask this to a lot of people, they would just think for a moment and spit out some number, right? Really just, and if you ask them to break down how they come up with that number, it would just be a total black box, right? Really don't know how they came up with that number. Is there any way we could come up with a more educated or more accurate or better guess of the number of professional piano tuners in Chicago rather than just picking some random number in our head? Well, one thing we can do is break it down into simpler questions where we're still going to have to guesstimate, but maybe they're a little more tractable. Maybe we have more better sense of these questions. So we might first start by asking, well, could we come up with an estimate for the number of pianos in Chicago, right? And we could break that down a little bit more too. So we could think, right, how many people are there in Chicago? Well, maybe that's a question that you have a better sense of, right? Maybe you know that the number is between 1.5 million and 3.5 million, right? So you estimate maybe it's somewhere in the middle, it's about 2.5 million people in Chicago, right? So you have some sense of that, right? And then you can ask yourself, well, what percentage of those people do I think own pianos, right? Any reason, well, most people don't own pianos. Most people can't afford pianos, and even the ones who can't afford them don't necessarily want them. So maybe it's only like 1% of people who have pianos. And what about businesses? Well, there are a lot of like schools and particularly music schools and such that might have a lot of pianos. Concert hall might have pianos. Some theaters might have a piano. So you want to beef up your overall estimate for the number of pianos on account of that. So, again, you're just guesstimating. Maybe you double it. Maybe you say about 2%, right? That's the relationship between the number of pianos and the number of people is about 2%, right? Or 2% as many pianos as there are people in the city. So you end up with a guess of 50,000, right, for the number of pianos in Chicago, right? This is breaking down this question into further sub-problems and at least coming up with some estimate for it, right? Seems somewhat reasonable, right? 50,000 pianos in Chicago. Okay, so now you can ask, right, how often is a piano tuned each year, right? And again, maybe you're going to have to guess here, but maybe people have pianos and maybe they're not tuned that often. So maybe you guess maybe about once a year, the family would have their piano tuned. That would mean you'd have about 50,000 tunings each year if there are 50,000 pianos in the city, right? Then you can ask, well, how long does it take to tune a piano, right? Because we're trying to ultimately work towards how many piano tuners do we need in the city. Maybe you think it took 2 hours. Again, you're guesstimating here, but it's a non-trivial task to do it, but it's also not a crazy long task. So maybe about 2 hours to tune a piano, right? And that would yield about 100,000 tuning hours per year in the city, okay? Now we know that we have 100,000 hours of tuning required. How many workers would it take to do that amount of tuning? So we want to ask, how much time does a piano tuner spend tuning pianos each year? Well, right, if we assume that piano tuners are like the average worker, working about 40 hours a week, 50 weeks, they're going to work about 2,000 hours. Well, you might want to correct for travel time, right? So maybe only about 1,600 hours is spent actually tuning pianos. And if that's the case, we can then figure out how many piano tuners are in Chicago by taking the overall number of pianos, 100,000, the overall number of tuning hours, which is 100,000 hours, by the number that a particular piano tuner would work, which is 1,600 hours, and we wind up with 62 and a half piano tuners. All right. If we go to the yellow pages, or at least at the time when Tetlock wrote his book, went to the yellow pages, so there are about 83 piano tuners listed in there in Chicago, although some of them were duplicates, so it may have been a little less. But this gives a remarkably accurate estimate, given that we were using so much guesstimating as we went around. We didn't really know any of the exact numbers here. We still were able to come up with a fairly reasonable estimate, right? By breaking that totally unknown problem, how many piano tuners in Chicago, into some more tractable sub-problems. So we can think of some other Fermi problems, just give us examples of the sorts of questions we'd have here. So the University of Maryland keeps a list of Fermi problems online that you can check out. These are all taken from them. So one would be to estimate the number of square inches of pizza consumed by all the students at the University of Maryland during one semester, right? Again, right, one way we could try to come up with an estimate would just be to just think about the question and come up with the first number that comes to your head, right? But that's not going to be a very accurate way to do it, right? A more accurate way is going to be treat it like a Fermi problem and try to break it down into sub-problems that are more tractable that you can come up with some reasonable estimates of. So in this case, right, one question you might ask yourself, well, how many students are at the University of Maryland, right? Maybe that's something you can have more handle of, right? You know, it's a big state school. You think it's bigger than UCI, but not like super big, not 50,000 or more. So maybe you think it's, in the 30,000s. I don't know how many people are at University of Maryland, but that could be your guess, right? Then you might think, well, okay, for each of the students, how much pizza is the average student consuming in a semester? How many slices are they consuming, right? Maybe you think, maybe we can think of it in terms of actual pizzas, like how many 14-inch pizzas does the average student consume in a semester? Maybe you think they consume like 3 or 4 pizzas, I don't know. And then you can try to figure out how many square inches are in a 14-inch pizza. You'd be the radius there would be 7 inches times, or squared times pi would give you the area of the pizza in square inches. So you get 49 pi as your in square inches as your area for a pizza, and if you think students eat 3 or 4 of those, you multiply it by that and multiply it by the number of students. Right. This is very rough and ready here, but it's right. This gives you a sense of how you'd break this problem down into sub-problems that maybe you could get a better handle of. Is a similar question, right? Estimate the total number of sheets of 8.5 by 11-inch paper used by all students at the University of Maryland in one semester. Here, right, you can have similar questions, right? Like, how many students are in the University of Maryland? How much paper is each individual student using, right? So here you might think about, well, how many classes is each individual student using, and how much paper would they use for each one of their classes, and how much paper would they use outside class, right? And you add all those numbers together, multiply by the number of students, and you have some estimate, right? How many notes are played on a given radio station in a given year, right? You might think about, well, how many notes are in a song, and then ask how many songs are played in a radio station over a year. Maybe you first think, how many songs are played in a radio station in an hour, and then multiply that by 24, and you get the number in a day. Multiply that by 365, and you get the number in a year, right? So each of these questions is sort of, right, when you first look at it, it's very opaque. Like, well, how would I possibly come up with a number for that? But if you break it down into simpler sub-questions, you can get surprisingly accurate results. There's still going to be error, certainly. Sometimes significant error, right, depending on how much traction you get on the sub-problems. But it's often, right, not going to be super off, or at least it'll be in the same order of magnitude as the answer you're looking for. All right. So takeaway here, right, is that when faced with a difficult forecasting problem, try to unpack it into simpler, more tractable subproblems. This is what the super forecasters that Phil Tetlock looked at in his book did, right? Now, be careful, though, to not ultimately replace the question of interest with a different question, right? These sub-questions really are not the real question that we're interested in. So we're not ending with them. We're just using them as a means to estimate the answer to the question we're really interested in. Okay, so this is a little bit about solving Fermi problems. Please remember to complete the participation poll for this video, and then move on to the next video on inside-outside views. Thanks, guys.